Maxwell's distribution of molecular speeds. In this topic, we will learn how molecular speeds are distributed among the number of molecules. So, this is basically a distribution of molecular speeds. It's not distribution of molecules among the speeds. So the concept is distribution of molecular speeds among the molecules. The question comes in our brain, need for distribution. Need for distribution. Why there is a need of distribution of molecular speeds among the molecules? Because molecules of a gas always in a state of random motion. Some molecules move slowly, some very rapidly. At the same time, the speed range of the molecules is very wide, and that is from 0 to infinity. The speed range is from 0 to infinity. During collision, they change their speeds, and the number of molecules present in the gas is also very large. So these are some basic reasons that there is a need of equilibrium distribution of molecular speeds among the molecules. I again repeat, molecules of gas always in a state of random motion. Some molecules move slowly, some very rapidly. The range of their speeds is very wide, that is from 0 to infinity. During collision, they change their speeds, and at the same time, the number of molecules is very large. Now, let us discuss the mathematical part of Maxwell's distribution. Eta C dc. Eta C dc is a probability. Eta C dc is a probability that molecule can have its speed between range C and C plus dc. I again repeat, eta C dc is the probability that molecules can have their speeds between C and C plus dc. ये प्रोबेबिलिटी है उन मॉलिक्यूल्स का जिनकी स्पीड C और C प्लस DC के बीच में होती है. Now DNC is number of molecules. Number of molecules in the range C and C plus DC. Eta C dc is the probability for range C and C plus dc, and DNC is the number of molecules lie in the range C and C plus dc. Now, suppose we want to get what is number of molecules DNC. So that is equal to capital N and eta C dc. This is probability for this range. Suppose your range is now C plus dc to C plus 2 dc. Then you have to multiply by some another probability for that range to get the number of molecules. DNC is the number of molecules for this range. Suppose you want to get molecules of other range, you have to replace this probability. So there is a need of just probability for another range. Will it be okay for you? Probability is a fraction. You know probability is a fraction. Let us shake. Eta C dc is equal to DNC upon n. Look, eta c dc is a probability which is nothing but the number of molecules in a particular range divided by total number of molecules present in the gas. Now, if you draw a graph of eta c versus c. Eta c is a Maxwell's probability distribution function. Eta c, I again repeat, eta c is Maxwell's probability distribution function. This depends on a particular gas, its molecular weight, its temperature, and different states at which it is present. This is molecular speeds. These are some range like 100, 200, 300, 400. This is in meter per second. The graph of eta c versus c will be like this. If you try to get any strip, that we will draw a strip. This is showing value of velocity as c. This is showing c plus dc, and the width is dc. If you try to take the area of this strip, then the length will be eta c and the width will be dc. Then the area of this strip will give you eta c dc, which is nothing but the probability, but area will give you probability for this range, c to c plus dc. Suppose you want to get a probability for some another range, so you have to draw the strip from that velocity to other velocity. And suppose you want to get the area under a complete curve. Area under a complete curve means the range of the velocity is from 0 to infinity. It shows that all the n molecules, where is that? All the n molecules lie under that category from 0 to infinity, and that's why we have to take area under a complete graph. So we will be getting probability which is maximum probability, and that is equal to 1. So your eta c dc will become n upon n, that is equal to 1. And this is nothing but is your Maxwell's distribution of molecular speeds.